Our next topic is self-organizing behavior of wireless ad hoc networks. Self-organization concerns organizing a set of mobile nodes with unique identifiers and wireless medium of communication into a connected network, which is able to do things like self-configure or self-organize. It concerns maintaining the structure when the topological changes occur, for instance with respect to node failure, node motion or link failure. Self-organization is very important in building scalable systems, particularly systems such as MANETs, which are decentralized and which is composed of typically large number of subsystems. The primary objectives of self-organization include coordination and collaboration to achieve shared goal, achieving collaboration without central entity, and improving or ensuring the reliability, the scalability and availability of the system. So, availability is all about probabilistically ensuring that as per the SLA, the system will be made available to the users for a certain duration of time. Scalability concerns that how the system would scale up, how the system is going to perform when the number of nodes in the MANET for in the case of MANETs, when the number of nodes in the system is going to increase. And reliability is all about probabilistically ensuring that the system is overall going to behave reliably at all durations of time when it is supposed to operate. So, there are different design goals of self-organization in MANETs with respect to neighbor discovery, topology configuration and topology maintenance. So, we are going to talk about each of these in more detail later on. So, self-organization is a behavior that occurs in the nature and that has been inspired from different natural phenomena and has been adopted in network systems. In this specific case, it has been adopted in mobile ad hoc network systems. So, in self-organized behavior, there are patterns which emerges at the global level using only local information generated by interaction between the low level components. So, for example, in the case of MANETs, local interactions between the different nodes which are within a particular local area, etc., and together they would that information would scale up to the overall network level, overall system level, and a pattern would emerge from that. Emergent behavior is another concept that comes very close when we talk about self-organization. It basically is a behavior of a complex system that is generated by simple interaction between lower level entities in more than to ensure that it is more than the sum of their behaviors. So, thus self-organization from a networking perspective includes the set of algorithms and protocols that govern global system behavior based on simple interactions between different nodes. For instance, simple message exchange between the neighbor nodes in a MANET that would lead to packet transmission from the source to the sink node. So, as we have seen in the previous lectures that in MANETs we have the scenario of multi-hop communication, and there are intermediate nodes, the neighboring nodes, which basically help in relaying the information between these two source and destination nodes. So, these things are powered by the self-organizing behavior, and this is very important. This example concerns message exchange, but similar kind of phenomena is observed in other aspects that other aspects that basically contribute to powering the MANETs. Let us look at the figure in front of us. To explain this phenomena of of self-organization, let us look at how the different nodes. So, in this particular figure, as we can see that we have a node which interacts with the neighboring nodes. So, these nodes they interact with the neighboring nodes. So, this particular node has local view about the behavior of the peers, and it can interact with the direct neighbors which are the peers, and this behavior can be observed by this particular node. So, everybody does the same, and together when we look at a systemic level, so this particular behavior, the global behavior of the overall system can be observed, or it can be approximated from these local observations. So, this is a very important aspect of enabling mobile ad hoc networks. So, in this particular figure, we see a comparison, a side by side comparison between self organization and conventional networking. That means, self organized networks and conventional networks. So, as we can see that in self organized networks, it uses local properties and rules. For example, the locally unique addresses, local connectivity, local clustering rules, distributed medium access, so on and so forth. All of these local properties and rules which can achieve or which can approximate the overall network functions or properties. For example, by doing all of these locally at this global level, at the system level, one could be able to get a global identification, a picture of the global the global context and localization, global connectivity, hierarchical organization, efficient use of resources, and so on. So, in a nutshell, what we see is in self organized networks, these local properties and rules can help achieve the overall network functions and properties in a in a very scalable manner. In contrast, if we look at the conventional or the centralized approach, so there actually we have global properties, for example, globally unique addresses, global connectivity, centralized clustering, centralized medium access. So, everything is centralized and it is global, the addressing scheme itself is global. Whereas, as we have seen in the case of the self organized systems, so the addressing is local, right. So, this is the contrast between the networking in the conventional context and networking in the self organized context. And whereas in the self organized context, we have implicit coordination between the different nodes. Here in the conventional context, we have perfect coordination. So, these are the main points of difference between the conventional or centralized approach of networking and the self organization approach to networking. So, the corresponding paper or the reference that one can read is given over here and in the bottom of the slide. So, one is encouraged to do so. So, in self organized systems, these systems basically use different approximate optimization algorithms to find optimal or near optimal paths, and the benefits of self organization include plug and play, right. So, basically one would be able to plug into the plug the system, and the system will start operating on its own. It is a fully autonomous system. So, plug and play technology, and where basically the new nodes which enter the network are automatically configured without needing any human intervention. Self organized networks have very distinct properties known as self configuration, which basically concerns setting the system parameters initially without external intervention. Self management is a second property, which basically concerns maintaining the current system configuration in terms of the current system parameters. Self adaptability, which is basically system's ability to adapt to the changes in the environment around the system. That means, in this particular case of manets, the nodes, they are going to interact with the environment around them, and the the system as a whole, the nodes individually and the system as a whole would be able to adapt to the changes in the environmental conditions. Self protection is basically the ability of the system to protect itself from external malicious influences, because in any networked system, and definitely in the case of manets, there are large number of different external malicious attacks or malicious interventions that can come in, and the system should be designed, the manet should be designed in such a way that it should be able to protect itself from such kind of external malicious interventions. Self healing behavior is about, as the name suggests, that whenever there is some kind of failure, then the system should be able to operate in the presence of such failures, and it should be able to recover from such failures. Two other properties of self organizing networks, properties of self organizing networks: self optimizing. So, it is basically the ability of the system to configure the local components optimally based on the global objectives, and self diagnosis, which is basically the ability of the system to detect faults and initiate self healing. Self organized systems, self organizing systems basically strive on the basis of different kinds of feedbacks that come in by interacting with the system. These feedbacks can be positive feedbacks, or these can be negative feedbacks. So, when we are concerned specifically of on routing, so the feedback negative or positive is used for erroneous path discovery in the different protocols. AODV, as we have seen in a previous lecture, is one of the very popular ad hoc routing protocol. Clustering is another, where the feedback is in the form of the remaining energy that is used to elect the cluster head. So, how much energy is remaining in the different nodes, and then switching between the different cluster heads. This is what this kind of feedback is used for clustering in manets. Then directed diffusion is something that is used in routing, in specifically in in the specific type of ad hoc networks known as the sensor ad hoc networks or ad hoc sensor networks, where the feedback is in the form of interest messages. Okay, so basically the different nodes which want access to the data, they are going to propagate interest messages for the data. So, we are going to look at the directed diffusion based routing when we talk about sensor networks, ad hoc sensor networks in more detail in a future lecture. Coordination is another, where basically feedback loops are used for synchronization between the different nodes, and collaboration is the last one, where positive feedback is used for auction based task allocation. There are different mechanisms of self organization, and these can be classified into the different forms, as you can see in the figure in front of you. One is the neural networks based mechanism. Second is game theory based mechanism. Third is reinforcement learning based mechanism. Next is the data mining based mechanism. Distributed artificial intelligence based mechanism, evolutionary theory based mechanism, and swarm and ant intelligence is another soft computing based approach or a mechanism that is typically used in powering or enabling these in these systems, these self organizing systems. So, there are different design paradigms for self organizing systems. Designing local behavior rules that achieve global properties, and then so it is basically about designing rules such that the interactions among the entities have local view of the network that leads to achieving global objective. This is the most important thing. So, locally, individually locally, the nodes in the MANET, for instance, MANET is a self-organizing network, is an example of that. So, individually locally, these nodes, they are going to interact with one another, and this local view is going to be projected at the global level for achieving the global objectives. So, this is a very important thing in self-organizing MANETs. Then there are other things like it is required not to aim for perfect coordination and exploit the implicit coordination between the different nodes. So, coordination is not explicitly communicated by signaling, right. So, basically the local entities are going to infer the details about the network through different local observation and scale it up globally. So, like this, there are different other design paradigms for use in self-organizing networks. So, two very important mechanisms for self-organizing behavior, self-organizing systems are known as self-configuring and self-organizing. So, so these self mechanisms, these two mechanisms, they are basically based on typical approaches known as the first one is the route discovery approach. So, when it concerns routing, so this is an example that is used in the context of routing, and routing is a very important phenomena for any network system and particularly MANET systems. So, route discovery, which can be done proactively on or on demand. Where basically the routes are discovered between a pair of different nodes whenever there is a demand. That means the the path between the source and the destination nodes are not already there, it is not already cached, and it is not available in the node or the nodes where the packet is currently resident. Route update, single or multiple routes are maintained between a pair of nodes, and and updating the current topology by detecting the node or link failures. So, route discovery and route update are two important routing mechanisms that are good examples for self-configuring and self-organizing behavior of MANETs. Self-optimizing is the next, which basically helps in improving the routes. So, some routes between the different nodes are selected through the routing mechanisms like route discovery or whatever, and then self-optimizing behavior characteristic, what it ensures is that the routes are optimal during the future time instance. For example, with respect to the route length, so initially maybe the route length or the number of hops between the two different nodes might be optimal, but later on also ensuring that the optimal path or the optimal route is used between the different nodes. That is what the self-optimizing characteristic, self-optimizing behavior ensures. Similarly, ensuring that it is energy aware and energy efficient is also another very important thing. Self-healing is a very important mechanism. Self-healing characteristic is a very important one for ensuring fault tolerance in MANETs. So, there are actually two types of fault tolerance. One is called the masking fault tolerance, which basically guarantees that the system will continue to function the way it is supposed to in the presence of faults, and the other one is the non-masking fault tolerance, which basically guarantees that when faults stop occurring, the system converges to configurations from where it continues to function. So, these are the two different approaches to fault tolerance which are used in MANETs, and these basically help in making these systems, MANET systems, the self-organizing MANET systems self-heal whenever there is a fault. So, adaptive systems and self-healing systems are quite closely related. So, adaptive means what? That whenever there is some kind of abnormality, some kind of problem, some unusualness that arises, so the system will be able to adapt to it, so that it functions the way it is supposed to function, right. So, this is what the adaptive systems does, and definitely self-healing systems are also supposed to do that. It is supposed to, these systems are supposed to heal on their own whenever there is a problem, whenever there is a failure or there is some kind of a fault. So, the system is going to self-heal. So, there are when we are concerned about the self-configuring and self-organizing properties of MANETs, there are different issues of MANETs that should be kept in mind, and these are the ones that we have already seen, but let us look at them once more. So, first one is that ad hoc deployment. This is a very important concept. So, we do not have a centralized entity, centralized coordinator like an access point or something like that, which can help in which can help the different nodes coordinate between themselves, talk to themselves, and so on. So that becomes a very important challenge, a very challenging problem in MANETs. The other is that the medium itself is very much error prone. Where the nodes operate, the medium is very much error prone, and there are limited resources, and the constraint on the energy is too high in these ad hoc networks, the MANET ad hoc networks. Okay, so the first proposed self-configuring protocols basically periodically discard the network topology information, and what they do is they rebuild everything from scratch. That means they try to rebuild the topology, understand the topology from scratch every time the network topology changes. Okay, so understanding the topology from scratch, building it from scratch, every time the nodes move, the topology changes, and so on and so forth. So this is what the native the previous route, the conventional mechanisms, this is how they achieve self-organization or self-configuration in MANETs. So different protocols, for example, the protocol LCA by Baker and Ephraimidis, and the link cluster algorithm, so etc. etc. These references already given over here. So so you are encouraged to go through them. So these are some of the protocols that basically achieved it through the mechanisms, the naive mechanism that I just talked about. And later protocols, the recent ones, basically consider a more gradual approach, where new connections are sought during random access periods, and after a timeout period, the connections that do not respond to a control call are declared unusable. One of the very popular self-organizing protocol that is used in MANETs is a routing protocol, is a cluster-based routing protocol, which is known as LEACH. The protocol LEACH, the full form of LEACH is basically low energy adaptive clustering hierarchy protocol, and it was proposed by Handy et al. In 2002. The application of LEACH protocol is typically found where it is required to have even distribution of power consumption at the different nodes in the network. So the LEACH protocol works under certain assumptions. For example, assuming that each node can either act as regular or cluster head, regular node or a cluster head node. The regular nodes only communicate with the cluster head. This is one of the assumptions that LEACH makes, that the regular nodes cannot communicate with one another directly, but they have to communicate via the cluster heads. So so they are within the one hop distance to the cluster head. The principles are like this, that the nodes, they elect themselves to become cluster heads at a given time depending on their remaining energy. The cluster heads broadcast their status to the nearest nodes in the network, and each node chooses the nearest cluster head to minimize communication energy. There are different limitations. It is not like so far what we have seen are all the very glittering aspects of self-organizing networks, and it is not that the self-organizing networks are all gold and they glitter a lot. It is not like that. There are different limitations of self-organizing networks. So if we look at this particular figure in front of us, what we see is that it's a curve, two curves, which basically shows the trade-off between determinism and scalability with respect to systems which are highly centralized, then the distributed systems, and the self-organizing systems. And as we are seeing that MANETs are self-organizing systems, right. So as we can see that when the systems become more and more self-organized, the determinism, basically the deterministic behavior, it reduces. So the deterministic behavior reduces from centralized systems through the distributed systems to the self-organized systems, whereas the trend is completely opposite with respect to the scalability. So with respect to scalability, the central self-organized systems are much more scalable compared to the distributed systems and the centralized ones. So, self-healing is an important property, as we have seen, of any self-organizing networks. Self-healing property basically increases the robustness in the network through redundancy, and so what it ensures is that if there is some kind of failure in the system or there is some kind of an attack, the system would be able to maintain the properties of it under which it is supposed to operate, right. So, whatever is the desirable system functionality, the system would be able to operate even in spite of the fact that it is under an attack or it is undergoing some kind of failure in some parts of the system, or maybe in the extreme case the whole system, the different components, large number of components in the system fails. So, the system will still be able to run. This is what the self healing behavior tries to achieve. So, in self healing, the system basically detects that it is not operating correctly, and with or without user intervention, it makes the necessary adjustments to restore itself to normal. And most of the self healing mechanisms that you would find that are used in these self organizing systems, that means MANETs and the like, we will see, I mean it is typically observed that most of these mechanisms are inspired from biology. And for example, the human body or even other organisms also, biological organisms typically have a strong immune system, and for instance, so if we just focus on the human system, we have a very strong immune system. So, what happens is, if we have a wound or a cut in some part of the body, typically the body is going to heal by itself. Or for example, if there is some kind of invasion by different microorganisms in our body, the body fights and our immune system fights, and the immune system would be able to heal on its own, would help our body to heal on its own. Okay. So, so most of the self healing systems are inspired from from the immune from how the immune systems work in nature, in biology. A typical system, any system, would typically go through 3 different states, as we can see in this figure. In the normal conditions, the system would be in the normal state. When there is some kind of failure, some systemic failure, then it goes to the degraded state, and after recovery it can come back to the system, it can recover from the degraded state and it can come back to the normal system state. Or if there is a detection of system failure, then it goes to the broken state, that means fail state, and from that broken state it can still, through the recovery processes, the system can be brought to the normal state. So, this is typically what happens in any system, and definitely for a self organizing system. So, there are 3 different aspects or critical aspects of a self healing system. Maintenance of the system, that means ensuring that there are some components which are replicated. Probing is another mechanism where data are collected about different components through different probes, and the other one is using performance log and analyzing the performance logs. So, this basically helps in evaluating, self evaluating the performance and self fine tuning the system. So, whenever the system failure is detected, basically what happens is, it is detected that something is missing, or some monitored value has gone out of range, or a foreign element has invaded and that invasion is detected. And the third is that recovery. So, recovery can be obtained through different mechanisms. Either the system can be repaired, that means the faulty components can be isolated, or the system can repair on its own the fault that has occurred, or through proactive mechanisms by ensuring that there are some components which are replicated, and whenever one goes down, there is another component that is going to take over. In summary, the problem of self-configuring and self-organizing behavior in MANETs is what we have discussed today. Self-healing behavior is a very important behavior of these systems, MANET systems, and the self-healing behavior basically ensures maintaining the reliable structure when the topological changes occur, when a link has gone down, for instance, when a node has gone down, or maybe there is some other fault or a failure that has occurred in the system. So, there are different general design paradigms for these self-organizing networks, and these are basically adopted from inspirations from biological phenomena, or evolutionary mechanisms, heuristic algorithms are often used, and so on and so forth. And so, when we look at this literature, we see that there are lots of theoretical approaches, theoretical results that are available in this particular context, and but when we look at the real implementation of them, they are still not very implemented, they are not yet implemented in real life systems. So, there is lot of opportunity of using them and implementing them in real life systems to make them truly self-organizing. Thank you.